Hello everyone, my name is Ankita, and I will be introducing the concept of complementary counting. Complementary counting is counting what you don't want and subtracting that from the total number of possibilities in order to calculate what you do want. This often allows you to avoid calculating multiple cases. Complementary counting is broadly applicable, and some of the main applications you see are in probability, where it simplifies casework, and geometry, where it's often used to find the area of shapes which have other shapes cut out of them, such as the square with a quarter circle cut out of it. However, it is important to recognize that complementary counting is not useful for every problem. You should think about what cases you would have to calculate if you directly counted versus the cases needed using complementary counting. And generally, you would pick the easier option to use when solving a problem. How many 4-digit positive integers have at least one digit that is a 2 or a 3? At this time, pause the video and see if you can figure out the solution before continuing to watch. Okay, so let's first think about how you'd solve this problem without using complementary counting. So just reading through this problem, what stands out is that we need integers that have at least one digit that is a 2 or a 3. So when we're given at least one, it could be 1, 2, 3, or 4, like we don't know. And this provides the basis for the different cases we use in this problem. So our first case would be that one digit would be a 2 or a 3. Our second case would be that 2 digits would be a 2 or a 3. Our third case would be 3 digits, and our fourth case would be 4 digits. Okay, so let's look closer at the case with one digit. So we have 4 different spots representing the 4 digits in our number, and we'd have one of these reserved for a 2 or 3. And looking at how I drew this, something you may be asking is, how did I know that the tens place, or like why did I mark the tens place as the location where the 2 or 3 would be? And the thing is, we don't know. The 2 or 3 could just as easily have been in the ones place or the hundreds place or the thousands place. And for each of these cases, we need to take into account which of these 4 digits are going to be the spot with a 2 or a 3. In addition to that, we also have to keep in mind that this first digit cannot be a 0, because if it was a 0, the number you'd have would not be a 4-digit number. So this is pretty complex. We have 4 different cases. We have to keep in mind which spots would be the ones containing the 2s or 3s, and we also have to make sure that the first digit is not 0. Now let's use complementary counting. According to the formula we had before, we have to subtract what we don't want from the total. So let's think about what our total is first. So what are the integers we're looking at in this problem? Well, it tells us here that we're looking at 4-digit positive integers. And now what is what we don't want? Well, in this problem, we're given exactly what we want, integers that have at least one digit that is a 2 or a 3. So what's the opposite of that? Well, integers that don't have at least one digit that is a 2 or a 3. And in other words, these are just integers without 2s or 3s. And we can actually calculate this in one case, which is much easier than the 4 different cases, plus additional complexity we had if we didn't use complementary counting. Now let's calculate this out. Let's first find the total number of 4-digit integers. So we have 4 different spots, each representing one digit of the integer. So let's look at the thousands place. So there are 10 digits, and we can use all of them except for 0, because if we used 0, then this would not be a 4-digit integer. So that means we have 9 possibilities for the thousands place. For the hundreds place, we don't have the same restriction on 0, so we'd have 10 possibilities here. For the tens place, we'd have 10 possibilities as well, and the same for the ones place. And now to find the total number of 4-digit integers there are, we'd have to multiply this out. So we do 9 times 10 times 10 times 10. And this yields 9,000. Now let's do this for the numbers without 2s and 3s. We'll do the same thing. We'll write out spots for each of the digits of the 4-digit number. Now let's first look at the thousands place. Similar to before, we can't use 0 here. And we also have the additional restriction of not being able to use 2s or 3s. So that means we have 7 different possibilities here. For our hundreds digit, we don't have the restriction of using zeros again. So we have 8 possibilities, as we still cannot use 2 and 3. Same thing with our tens digit, and we have the same case with our ones digit as well. And now if we multiply this out, we get 3,584. We can subtract this from the total to get the numbers with 2s or 3s, which is what we're looking for. 9,000 minus 3,584 yields 5,416, meaning that there are 5,416 4-digit numbers that have at least 1, 2, or 3.